Hello, everybody. My name is Dovydas. I am from the Artificial Intelligence Association of Lithuania. Today with us, we have Daria from Accenture. Daria will deliver a very interesting presentation about reinforcement learning. We have been, we used to have more reinforcement learning presentations before, but it has been really a while before we had a presentation about this topic. So I'm really excited and curious to see what Daria has to say. And Daria, the floor is yours.
Hello, everybody. My name is Daria once again. Actually, I am senior data scientist in Accenture. And first of all, I'm going to tell you a little bit about Accenture. As you know, that Accenture Baltic ATC includes two countries now, Latvia and Lithuania, and we have data and AI capabilities there. A lot of experienced people, and actually a range of our projects are very wide. We are doing a lot of projects with chatbots, a lot of projects with computer vision, and actually pure data science also. And currently we have several projects connected with reinforcement learning. I will demonstrate some of them later in the next slide. And also, we are working a lot with clouds as AWS, Google Cloud, and Azure. And also, we have a special platform for conversational AI where we could easily develop chatbots for different projects, not from scratch, but from pre-trained models. And I think that's it about our capability. Let's move on to our topic, reinforcement learning. Which agenda we have? First of all, maybe I just made some introduction what reinforcement learning is. Just in simple words, actually. After that, I'm going to demonstrate you some reinforcement learning projects which Accenture have right now. And after that, even we cannot do something by hands, but I could suggest you some special environments and resources which can help you to try anything if you have to start to work with reinforcement learning, or just if you look for new environments for your model training. And of course, questions. But in case you have some questions during my presentation, please don't be hesitate and write in the chat. I think I can answer on all of them. And let's start. Actually, what reinforcement learning is? Some people just thinking that it's some separate field of machine learning and mostly connected with robotics. It's not such appropriate way, but if you just can think about three basics in machine learning: supervised learning, unsupervised learning, and reinforcement learning. Actually, reinforcement learning has a difference from two first. What supervised learning it is? Actually, it's a learning when we could label data ourselves. And when we could just show the to our model just a dependence between input and outputs. The example of this, just if you don't know object detection, I think which my colleague Victor delivered last time. And unsupervised learning, it's machine learning actually when we don't have to label data, but it's more about clustering. I think K-means and hierarchical clustering is also example of this. When the model try to make dependencies between data itself. But reinforcement learning is maybe not something in the middle, it's something different. Actually, when we try to train some agent to get states from environments and actually make a decision which step it has to do. If we just try to find in Wikipedia what reinforcement learning is, you can see this statement that reinforcement learning is an area of machine learning. Of course, it's obvious. Concerned with how intelligence agent ought to take actions in the environment in order to maximize the notion of cumulative rewards. And this picture, I think it's the most popular picture regarding reinforcement learning. And based on this picture, a lot of people just thinking that reinforcement learning is kind of robot. Let me disagree with you, actually. Because yes, we try to train agent in reinforcement learning, kind of robotics, but all states which we just can show the robots, it's not purely from environments, it's from observer, from entrepreneur. And of course, rewards, it's also how observer can make an award, how good or how bad just agent is doing. And based on these basics, actually agent should make a decision which next action it should do. But in our demo, actually, I am going to tell you how we can try a goal for reinforcement learning and actually what we should think in what we should pay attention how to help agent to select next actions. Basically, it's also true that sometimes we can use reinforcement learning with a supervised learning. In such case, the observer just can help to agent to make an action manually. It's kind of supervised learning, but for example, if you have a remote control of your robot and you can just show a correct step for them based on some statement or states from environments, of course it can work, but first time you should do it many times. If you don't do it first time, agent can do something randomly, and after a lot of rounds, it can just establish dependencies between state and action. Okay, let's go to the next slide. What actually is the main ideas behind of reinforcement learning? The simplest what we can understand. First of all, that we don't need a lot of labeling data set in advance. We don't need a lot of pictures, a lot of, I don't know, text of sounds or something like that, a lot of words. It's a plus, basically. But in opposite case, you should organize an environment and put agents there. And of course, you should not only organize environment, you should decide how the agent can get states from it. Basically, just imagine that you have an animal, I don't know, a dog, and you just train your dog to ask a food, just show some good behavior. Of course, dog can train that after some good behavior, it can get a food and will repeat this action again and again. In such case, you just provide an environment for dog, how it can recognize states and make a decision which action it should do, just to get a positive reward, a food. Actually, it means that animals are capable to do reinforcement learning, very interesting things. I think the scientist Pavlov just proved that dogs can do it. But for agents, for reinforcement learning agents, you should understand that from scratch, it doesn't know anything, really. Just vacuum actually, and you should repeat a lot of times this training. It means that you should just provide an environment where agents should train a lot of rounds. And of course, it's really hard to do it in the real world. Basically, I think a lot of reinforcement learning just do it in different virtual environments. Because in virtual environments, you can increase time. You can just provide some special statements, and actually not only observation like from cameras, but also from some sensors. For example, if you are driving, which inputs just person as a driver can get from environment. Of course, he or she can see by eyes, can hear by ears, and can sensor by skin. But from virtual environments, you can also establish some additional inputs. Because in virtual environments, you have an information regarding coordinates and how far, for example, obstacles from your robots or agents, and how far goals from your robots and engines. And please don't make a mistake and don't include in your training some special special abilities of your of your virtual environments. Because if you are planning to transfer your model from virtual world to the real world, you should understand that in the real world your agent cannot get such inputs, because in the real world we don't know actually how far the cat who is crossing the road in front of your car allocated. And of course, the main problem, as I already mentioned, to transfer from virtual environment to real environment. Because just imagine, you have a virtual environment, you establish everything, you made a training, and actually your agent just show very good behavior in virtual environment, and you just it would be good if I transfer my model to the real robot, for example. And it failed. Why? Because actually real environment is very different. Even if you just establish the same background, the same floor, I mean the same color of floor, for example, and the same parameters, it's very hard just to, for example, to avoid some shines or some mirrors or something like that. Or anyway, your model will work perfectly only in some closed room, like a bunker, for example, with completely looking as a virtual environments. In such case, for real worlds, you definitely should train some additional reinforcement learning training in real worlds also. But you have your pre-trained model from virtual environments. It's also might be useful. Let's move on. Actually, for which cases we can use reinforcement learning? I think the most popular, and everybody of you already know that reinforcement learning we can use for game development and even testing. I saw some practical use cases where people are testing games just using reinforcement learning. For example, OpenAI 5 team from OpenAI implemented some special team from 5 AI bots in Dota game. And sometimes they also won a special round just to compare with the humans, actually. But of course, you should understand that in games, actually, it's not so big difference between levels, for example. Of course, you can update levels very often, but reinforcement learning agent, like a good reinforcement learning agent, can adapt with all levels. But of course, game it's not a real world, and let's talking about some self-driving cars and trains and even planes in real world. Actually, it's also used reinforcement learning, but I know, for example, one project regarding self-driving cars, which also used not only like pure reinforcement learning, they also used supervised learning when experienced driver just can show an agent how to drive carefully, and based on this pre-trained weights, agent can train more accurately if it just started from the random weights. Of course, reinforcement learning using for robotics. I had some cases with robotics. I will show you later. And especially some from robotics arms. But we also tried to do some cases with robotic arms. I think my colleague Victor already mentioned about it. It's regarding Apple Picker project. I will show you some demo later. And for board controls, actually, it's not only about self-driving boards, because reinforcement learning can be trained to control boards not from engine, but also from wind controller. I mean, just to repeat special techniques from person, and for example, just control a boat under the wind. I saw some simulation. I will show you some link where you can try it yourself if you want. And also, reinforcement learning could be used for traffic scheduling. we had some traffic in Accenture. It's called solution like smart traffic. Mm, and I think we also can named a lot of more use cases where reinforcement learning could be relevant, but maybe you have some interesting project and you can just put it in the comments in YouTube. I'm also really very interested in what else can do, but let's move on to the next slide. Okay, and now I'm going to tell about some Accenture reinforcement learning projects. Actually, we just have started to work with reinforcement learning 5 years ago, and we had started with a small robot, Now robot. Now robot, it's not really complex robot. It was created mostly for universities or for some school lessons, but our idea just was just to create a little helper for people, for old people, for example, or just sick people who cannot clean their house himself or herself. And first of all, we had a task to train our robot to pick up a ball. And after that, of course, we are going to expand this for another different things, just to pick up everything from the floor, to clean the house. And first of all, we try to train now in a virtual environment. I think now you can see it's a special virtual environment for Now robot. Actually, I don't remember the name of this software. And also Now robot has an ability to record movement. And in the future, you can just call this movement as an external library, and robot just repeat it. We recorded some movement when robot can pick up the ball, and the rest of things actually what we leave just to put a robot in a correct position to help him to pick up the ball. And for that, we had a lot of rounds to train it in real environments. Actually, I can show you video. It's one of successful case. But for virtual environments, actually, we cannot create a stable virtual environment which really repeats our testing room. It's a Liquid Studio actually in Riga, and that's why we had to retrain our robot in real environment. But we had some problems there because in Riga Liquid Studio we had a lot of mirrors and glasses, and of course we had a lot of problems with shining, scheduling, shadows, and if some people just appeared in front of Now, and that's it. I think it's not so, yeah. You can see that, first of all, robot just absorbed and select the direction actually where it could move, but it's not so fast. This training has been done only for 3,000 rounds, I think. Because it's a real environment and we cannot increase the time to make it closer. And currently, I can show you that pickup in movement is not so ideal also. Here you can see that the robot just made a mistake, and currently he's trying to correct it to make it closer to the ball. And but okay, we have some questions. I think I can answer questions right now, right? Is it safe to say that reinforcement learning boils down to solve and updating the Bellman equation after each iteration? What does it mean? Is it safe? I think so. Yeah, it's safe. Why not? Yeah, and how you know when an enforcement learning agent is ready for production? Zero fails? Well, actually, it's not a zero fails, but we have some special precision. And if an enforcement learning agent is doing with 98% of accuracy correctly, yeah, it's ready. But in such project we have when clients just make these requirements, how precisely it should do, what the accuracy it should do. I mean, okay, let's move on to the next demo. Yeah, it's our smart traffic solution. Actually, the main idea behind that, just imagine that you have a lot of traffic jams, and it's because that some traffic lights doesn't work correctly. Uh, it's like follow some scheduling, but if traffic lights could adapt to the traffic jams to the line of cars, it means that we can control actually our traffics more carefully, I think. And we just selected Sumo virtual environment. I think you know about it. It's looks like simulation of urban mobility. It's special virtual environment where you can simulate traffic, city cards, and some pedestrian activity, and that's it. And just implement very simple reinforcement learning with simplest Markov decision processes, I think, and just also added some fuzzy logic for our traffic lights. It means that it shouldn't be a precise time when it should be red light or just green light. It's always just suggest different intervals based on which lines we have, and also can make some predictions uh, based on time of day, which lines actually could be in this time, and just suggest some intervals for red and green lights. I think we also can do a video here, but how do you think actually what's the difference from these virtual environments to the real environment. Because you can see here we have some arrows like left, strict, and right, and every car just select randomly the direction what it could drive in. Of course, if it's green light, but for real person, for real drivers, we had a special track actually, and the goal just to drive from point to point. And in such case, we definitely know where we should turn or just drive strict. And based on this special tracks, special lines from point to point, it also could be trained in the real world, but we didn't do it yet. We just cannot simulate this in our virtual environment. Not because we can't, we just didn't have time for it. Okay, let's move on to another use cases. And yeah, different use cases also connected with the car. It was a competition which was provided by Amazon, not only for Accenture. I think it was a competition for all Amazon partners, and they also provided a car here and a trace. The idea behind it is that AWS just create a special deep racer solution and put it in a cloud, and you can just use this special solution, train your own model. It was already connected to the Gazebo virtual environment and to the SageMaker. You just can you just was be able to create your own special model for reinforcement learning agent and train it. And also they provided two types of competition, one of them only in a virtual trace, and the second of them just to repeat your success in a real trace. And the main idea was also to transfer a model from virtual world to the real world. But it was really funny that some different teams just get different backgrounds and different race. Of course, it couldn't be compared, but it means that we should train a model which not only just can be trained to drive only in one type of trace. It means that it should predict actually which type of trace it could be and could drive based on prediction, not only make some action based on previous state. I think it's more connected with semi-supervised learning, not only pure reinforcement learning, because you also could, I don't know how to say, the person, like the observer, should show to the car different variants in every point of action, and just investigate all variants and calculate all probabilities. The car should make a choice what step, what action it should do, and to get the maximum reward. Here you can see a link. Actually, it's one of our Accenture Germany colleague who just took part in this competition as a Germany department, and he got an award in the top 8 in the world. And there he just described very precisely how we can predict the behavior of the car. But for Riga team, we also just used a lot of pre-trained model from virtual environment, but we had very big difference between virtual environments and real environments. You can see that in virtual environments, we even don't have a wall, like limitations, but here we have, and our car just make an input, just get an input through the cameras only, and that's why it couldn't be so precise. Okay, let's move on to the next slide. Apple Picker Robot, I think it's one of the biggest project with reinforcement learning where Accenture just working on. It was a project with collaboration with Latvia University, and the main idea behind just to create a robot from scratch, real robot from scratch, which was be able to find and pick up apples from the ground, not from the trees, from the ground. And in the beginning, one of our owners of this project just named it like a digital baby, because we were going to train this robot as a baby from scratch. But we created just global architecture and just selected as a base for the robot iRoomba vacuum cleaner. And maybe you know that iRoomba vacuum cleaner has a bumper sensors, and of course it should be used like an input for an reinforcement learning agent. We put a camera, and we also put some lasers which can just to help us to navigate where is the apple is located. Two lasers, and actually the main idea was that apple should be located in the crossing of these two lasers. And based on this, we just created a reward system, and it was like a reward from 0 till 1, but with different disperse. And also we just put some multi-goal system. It's like not only one goal just to pick up apple, because it's not so precise, right? It just has a range of goals, like find as much as it can apples, just put in precise position to pick up apples, and actually to do it as fast as it can. And for this one, we implemented direct future prediction. It's also not a pure reinforcement learning. It's kind of supervised reinforcement learning, because here you can see that we are using two different neural network. One of them just to provide some expectation, actually, what next state it should be, or what is the range of next state it should be. For example, if robot can see a wall in front of it, he just can calculate the probability what it can do to turn in the right, to turn on the left, and to make step away or something like that. And also we integrated some computer vision apple detection model, and also put some calculations, like simple mathematical calculations. If the robot can see an apple in front of the screen, and after the next step apple will be bigger, it means that it just made a step in correct way. And of course, it also was be analyzed a result from previous section. First of all, we tried to create an virtual environment, and we selected Gazebo. Here you can see the robot. It's iRoomba. It's a camera here. It's a laser simulation. Yeah, it's apples. Yeah, and the computer vision model wasn't trained by us. It was already pre-trained model. That's why maybe it's not so precise, because it's not a real apple. And we just leave it to train for 50,000 rounds. And here you can see like a result. The robot can avoid obstacles and can pick up apple, but now you can see the trick here. You see, in the camera, this apple will be absent, and in real world, the robot cannot see this apple, but he just mentioned that apple, that apple located there, and that's why he just pick up them. After 50,000 rounds, we transferred our model to the real robot. But for real robots, we also have a lot of problems with the drivers, because we wrote them from scratch in ROS, Robotics Operation System. And for real robot, we should also implement some manual control. I think in the next slide, yeah, I have another demo with real robot. We also tried to implement random positions of apple for every round, but in such case, it will increase time of training, I think maybe in 10 times. In such case, we just started with a not random position of apples. And here you can see that it's not like a real apples, it's more similar to balls, because we should just show robots that apples not only red color, it also has some special pieces of another color, for example, special spots of another color. Okay, one more round. And also, first of all, we just implemented not only like rounds, we also implemented some special games which consists from 15 steps. And if during 15 steps robot can pick up 1, 2, and 3 apples, it just could get more um, more reward, like in 10 times more reward if it just doesn't pick up any apples during this round. Okay, let's move on. Yeah, and actually here it's our first prototype. You can see it's not a real arm, it's kind of pipe with a spoon. And we don't have a basket actually here. And during first test, we actually faced with the big problems that real apples were too heavy for this robot and just make it not so stable. And that's why we just have to provide some special test with fake apples from plasmas, not like real apples. Here it's a training in virtual environment, and I think you already guess what's the main problem also there. It's a time delay. Because in virtual environment, of course, we have no delays because you can just do a step, I don't know, in 1 second. But for real robot, it takes time. And that's why we just need to adapt our reinforcement learning training just to implement this time delay. And I think one more thing there that in Gazebo we had some problems with physics. Of course, you can simulate all parameters, all geometrical parameters for robots, but we have some problems with the physics. For example, if apples just falling down, it's doesn't behave correctly like in the real world. And actually it doesn't move correctly in some times because maybe you know about some bugs in the virtual games. We have some textures or something like that, and some characters can cross or can struggle out in the textures, and in Gazebo we have the same problems. And that's why it was so weird to transfer our model to the real world. You can see that here my colleague just tried to show robots the correct way, kind of supervised learning. But we had to create a new manual round, like I think for 50 rounds just to do it manually in the real world. I think here the same. Actually, maybe first time it looks scared because it's some not so beauty scene. Try to look for someone. Maybe it's going to hurt, like yeah, but you can see that actually it's look for apples, but if it does not look for apples, it didn't try pick up. Yeah, here, apple. It lost it. Almost there. Yeah, and it's also lost it. Yeah, and one more thing that I forgot to mention, actually, it's inertia. In Gazebo, we had really big problem with inertia. You can just program some inertia, but it doesn't work in the right way that time. I don't know why, because I checked everything and it just didn't provide inertia like in real world. Okay, I think it was the last demo for today. And currently I'm going to tell you what you could try in reinforcement learning, some resources. What you can try. Actually, the main resources for the beginners, or if you don't know about it, just try. It's a gym from OpenAI. It's environment which already provided some special pre-training model for tasks like this one or some lunar spaceship. And of course, you can play with the policies there. You can try to train it yourself. And I think the most useful thing there that you can just implement this environment like a gym in your Python code for your own reinforcement learning and just train your light model there. Actually, it works for these light models. It works only not only even without GPU machine, and you just could try in your own laptops. The second thing, of course, you could also try. It's a gazebo. I think it's a very popular in, virtual environment, but of course, be aware about some special differences from the vault. But it's easy to implement in ROS, and it also has a lot of external free libraries with robotics. You just can select kind of robot which you are going to train and just put it to your vault. That's it. Yeah, and also you can select some special already created vault. It means that you don't have any headaches how to create your own vault. Just to select existed vault, to select existed robot and implement your reinforcement learning. That's it. The next thing, it's a ROS, of course. Basically, ROS, it's robotics operation system, and the main idea behind is that you have a topics, and you can subscribe on different topics, like can subscribe any functions to the different topics. For example, for my robot camera, I have a special topics camera with different settings, and I just subscribe my Python function like as an input, put my camera as an input, just subscribe on this topic and it works. Also, ROS could be integrated not only with Python, you also could integrate it with C#, C++, I think. I'm not sure about Java because I haven't tried it. Yeah, but I think you could try. And also ROS have a very big community. Maybe we can compare it with Stack Overflow, and even if you have some problems, you can just write in the chat, in the forum, yeah, and a lot of people will be glad to help you. Okay, let's move on. Also, you can try Blender. Blender, it's also open source, but of course you could donate for it. Maybe you know that Blender, I think it's one of the most popular program for 3D cartoons. And actually, we tried to use Blender for another project in Accenture. It's not connected with reinforcement learning, but it's connected with a sign language translator. And just to be very short, we just with the Kinect help or through Kinect, we just record people movements, like person who is showing sign. It's like Latvia in island sign language. After that, we just check this animation and put the to the character in the Blender. That's it. Yeah, but it's also very powerful instrument. I think Unity is also could be analog of Blender, but I think for Unity you should pay. But for your own project, you can just use Blender without any payments. And one more, RL Leap. It's a scalable state of reinforcement learning. I think it's created especially for reinforcement learning. It has very good documentation and also has a lot of pre-trained model with reinforcement learning, which you could just try. And I don't have a picture here because honestly, I haven't tried myself. But I know that our Germany colleagues tried a lot, and for some clients, it should be useful. I think that's it from my side. If you have some questions, please don't be hesitate. Thank you for your attention. Waiting for your questions.
Yeah, so we don't have any questions right away, but typically they appear after some time. I actually have a question while we wait for others. I'm actually very interested if there are some new exciting developments, I mean, in 2022 or the end of the last year in the reinforcement learning field.
You are talking about some development which just appeared or which you can try yourself?
Maybe what are you excited about? What are you mostly excited about which new development in the, I guess, in the field?
Well, maybe it not in 2022, but it was in 2021. It was from NVIDIA, and they just created special, not a framework, special model which could easily track any movements of people, even in a dance. But of course, it's not so new. But this thing could predict a human behavior and actually could be used to prevent some attacks during robbery or during some war actions, something like that, military actions.
All right.
Yeah.
Very interesting. I haven't heard about this model, but it might be worth to check it out. Let's see if we have any more questions. Yeah, only the questions which you already answered during your presentation. I actually have one more, so while we're waiting, anyway. Do you have any suggestions how to actually, like, I mean, more in a sense of books and courses, how to learn, how to get started with reinforcement learning, but not necessarily just trying it out yourself in the gazebo sim or OpenAI gym, but more from the learning point of view?
Well, I found very interesting course in Coursera. It's regarding self-driving cars. I just found it's really very interesting, and they also used kind of reinforcement learning, but of course not a pure reinforcement learning, but also like supervised learning also. And I think, yeah, that's it. And also, I think the most interesting, which I see, it's in Udacity. It's regarding autopilot for drones, some kind of autopilot drones,
All right.
something like that. Yeah.
So a self-driving car course in Coursera and drone piloting in Udacity.
Yeah. Yes.
Okay, cool. Let's see. Oh, I think we are out of time, and we don't have any more questions. So it was really nice having you here, Daria, and thanks for your presentation.
Thank you.
Right, and for all the viewers, thank you all as well. See you in our next meetup, and bye bye, everybody.
Bye bye.